Am I audible?
Yes, sir.
Okay. Yes. So let's move towards the last point of chapter number one. That is the microcontroller based control of stepper motor. Okay. So in previous lecture we have discussed two control strategies for stepper motor. First one is the open loop control of stepper motor, and second one is the microcontroller based closed loop control of stepper motor. So we have discussed these two strategies in previous lecture. Now only one point is remaining, that is last point from control strategy, which is the microcontroller based control of a stepper motor. Okay. Now there is a vast area to work in this particular control strategy. So person to person, someone may make a certain modifications in the microprocessor programs, and accordingly, particular person will achieve the different control strategy for the stepper motor. Okay, so this entirely depends upon what type of program we are going to feed in microcontroller EEPROM memory. Okay, so depending upon that particular program, whatever microcontroller will give the logic sequence for the operation of the controller, sorry, operation of the stepper motor. That logic sequence is nothing but simple. The logic sequence of by which we excite the different phases of stepper motor. So that is simply what type of excitation which is provided to the different phases, and accordingly we achieve the desired step angle and desired stepping frequency. Okay, so that entire thing depends upon the program which is fed in the microcontroller memory, and according to that program, the microprocessor goes to the lookup table for the logic sequence of excitation, and accordingly, the different phases of stepper motor stator get excited, and we obtain desired phase angle or desired step angle and desired stepping frequency. So for each and every control microprocessor based control strategy, the general block diagram is as shown in figure 1.4. So there is a nothing difference in the block diagram. So whatever flow is there, whatever block diagram components are there, that entire components are same. Now, in control strategy, basically we are interested in the control sequence or logic sequence which is provided to the stator winding of stepper motor. Okay. So, whatever stepper windings are there, that stepper windings are generally connected in different control strategies, and according to the logic sequence which is generated by the controller, the stator winding will get excited. Okay, and accordingly we obtain desired step angle, desired stepping rate, and the desired direction of the stepper motor. Okay, so here also, whenever we are going to uh, apply or whenever we are going to implement the microprocessor based control strategy, then the stator winding is excited with the different phases, and this particular excitation is provided through the different power electronics or power semiconductor devices. Okay, so each and every power semiconductor device has its own driver circuit. So this particular driver circuit is generally excited with the logic sequence which is generated by the microprocessor, and accordingly it will excite the particular stator phase. Okay, so there is a conventional excitation scheme is actually the in every phase of stator of stepper motor, there is a one semiconductor switching device. That semiconductor switching device may be SCR, MOSFET, IGBTs, and the gate driver circuit of that particular semiconductor device is excited with the logic sequence which is generated by the controller. So that is the simple way of any control strategy which is provided or which is implemented for a stepper motor. Same logic is there for open loop control strategy as well as for closed loop control strategy. So whatever the switching sequence which is generated by the particular control strategy, that particular switching sequence is applied to the gate driver circuit of a particular switch, that is particular semiconductor switch or semiconductor device which is present in a particular stator phase. Okay. So we generally provide this logic sequence to the driver circuit of the semiconductor devices. Okay, that driver circuit is actually the gate driver circuit of semiconductor devices. So every semiconductor device has its own driver circuit, and there is a one semiconductor device present in each phase. Okay, so that is about the driver circuit block. Now there is a microprocessor which has the memory. Then it has the PPI. What is PPI? PPI is nothing but the programmable peripheral interface. Okay, so this is actually the PPI. So these are actually PPI parallel ports where we interface IO devices. That is the input output devices. Okay, and that microcontroller has memory and PPI, and whatever logic sequence which is generated at these PPI parallel ports, that particular logic sequence is given to the gate driver circuit of these semiconductor switching devices through opto isolator. Okay, so in between this microcontroller and gate driver circuit, or in this between this controller and gate driver circuit, there is a isolation provided, and that electrical isolation is provided with the help of opto isolator. Okay, now what is basic function of this opto isolator? Opto isolator is generally the device or component which is used to provide the electrical isolation between two circuits. In each and every control circuits, or in most of the control circuits, we use this opto isolator to provide electrical isolation between control circuit and power circuit. Okay, now what is meaning of this control circuit and power circuit? So whenever we talk about the power circuits, then power circuits are generally of a higher voltage and current ratings. Okay, so when we talk about say stepper motor, definitely the power circuit of that stepper motor is nothing but the excitation voltage which is provided to the each phase, and the excitation current which is flowing through the stator winding of each phase. So basically these particular power circuit ratings are high as compared to the control circuits. So when we talk about the control circuits are generally low current and low voltage rated circuits. So these particular circuits are generally rated at a lower parameter or lower value parameter, and if there may be any chances of faults which takes place on power circuit side, that faults may be due to the short circuit present in between any phases, or that fault may be due to open circuit which is exist in this stepper motor, that fault may be due to transients which takes place on this power circuit. So there may be chances of increasing the currents and voltages associated with the control circuit. So whenever there is a certain fault takes place on power circuits, then there may be chances of damaging the control circuit of the particular control strategy or scheme due to these higher voltages and currents, because whenever fault takes place on the power circuit side, that will definitely leads in increase in voltages and currents, or maybe there is a fall in voltage and rise in current according to the type of fault. So when we discuss short circuit faults, there will be rise in currents and fall in voltage. When we discuss open circuit fault, there will be rise in voltage and fall in currents. When we discuss transients, then in case of transients, for shorter duration of time, the parameters which are associated with circuit like a voltage and current, that parameters increases, and that transients may be arises due to the switching action, that may be arises due to the traveling waves, or that may be arises due to the lightning phenomenon. So these are the various causes of faults which takes place on power circuit of uh, any control scheme. And whenever there will be fault takes place on power circuit of the any control scheme, and if there is a no any electrical isolation provided between control and power circuits, then these faults which takes place on power circuit leads to increase in values of currents and voltages associated with control circuits, because control circuits are generally operated under lower value voltages and currents. So under these particular conditions, there may be chances of damaging the control circuits of the entire control strategy. So we have to provide a certain protection for these control circuits, and that protection is generally provided in terms of opto isolators. Okay. So there is a isolation provided between control and power circuit. The isolation means opto isolators, that means there will be no any electrical connection between control and power circuit, but whatever control signals which are generated by control circuit, that control signal will passes towards power circuit through opto devices. That means there is a one opto emitter, and second one is the opto collector or opto sensor. That is nothing but opto emitter is nothing but simple your LED. That LED is nothing, LED acts as a emitter, and opto sensor or opto collector is nothing but your simple photodiode. Okay, so photodiode sends the light signal, and accordingly it will generates the voltage at its output. So in simple, when we talk about this opto isolator, then this is the simple opto isolator circuits. Okay, so this is whatever uh, opto isolator which is present. That opto isolator consists two different components. One component is the opto emitter, or that is also known as the photo emitter. Okay, and another component is the photo sensor, or that is also known as a photo collector. So this photo emitter is generally LED, and this photo sensor is generally photodiode. Okay, so there is a no any electrical connection between the input side, that is emitter and collector. In simple, we can say that there is no any electrical connection. So whenever there is a certain amount of control signal which is generated by this PPI, this control signal is of certain voltages, and that voltage or that control signal glows this LED. That means there will be glowing of this LED takes place. So whatever light beam which is generated by this LED, that light beam get fall on this photo diode, that photodiode, or in any simple collector device. Okay, so generally opto isolator consists of photodiode. Okay, so whenever the light beam which is generated by this LED is fall on this photodiode, then there will be formation of the EMF across its terminal. So there is a formation of a voltage, and this particular voltage is given to gate driver circuit of a stepper motor uh, control circuits, or sorry, stepper motor driver circuits. Okay, so this particular voltage is applied to gate driver circuits, and accordingly the particular phase of this particular gate driver circuit will particular phase will get excited, and motor will runs with a desired step angle. So when we talk about this opto isolator, there will be no any electrical connection between the control circuit side and the power circuit side. Entire things are transmitted. Whatever control signal is there, that control signal is transmitted in the form of light. So whatever light beam which is generated by this LED, that light beam is proportional to the voltage, control voltage which is generated by PPI. Okay, and this particular light beam is fall on this photodiode. That here this is not a symbol of photodiode. Okay, so generally we use photodiode in opto isolators. Okay, or it is simple any collector. It is any photo collector device. So whenever this light signal which is generated by this LED or emitter fall on this photo collector, there will be generation of EMF across this photo collector, and this particular EMF is applied to gate driver circuit of a semiconductor devices. Okay, so this is the general block diagram for any type of the microcontroller or microprocessor based stepper motor control scheme. So that consists a microprocessor with a memory and PPI, then opto isolator to provides electrical isolation between control circuits and power circuit, then driver circuits of the semiconductor devices which are connected in each phase of the stepper motor, and this entire thing is connected to stepper motor stator winding. Okay, so depending upon the input stepping rate and the direction command, so what is the input provided to this microprocessor? So that input is actually the stepping rate. That means what much stepping rate is required. Second one is direction. Addition to this stepping rate and direction, we can provide another sort of inputs also, that is nothing but the theta s, which is nothing but the step angle required. Okay, and fs is actually stepping frequency required. Okay, so we can provide these particular inputs also to the microcontroller, and we require this particular desired parameter at the working of or at the stepper motor side. That means, say we provide theta s is equal to say 15 degree. That means the microcontroller or microprocessor should command a logic sequence in such a way that after receiving each pulse, excitation pulse to each phase, the motor will tries to run with a step angle of 15 degree. So these are actually the desired value of operation for the stepper motor. Okay. Now, these are the inputs. So, general inputs are the stepping rate and the direction commands, which are provided as the inputs for every pulse which is received at the driver circuit. Okay. So, according to this stepping rate and the direction command, the microcontroller goes to the lookup table of a logic sequence for exciting stator winding, which is stored in EEPROM and output to next step as a word on PPI parallel port. So actually again here, after receiving first excitation command to the stator winding, when this first cycle get completed, then and then only there will be initiation of second cycle or second input command. Okay, so that entirely depends upon whatever the logic sequence which is stored in EEPROM of stator winding, and the output to the next step which is generated at the PPI parallel ports. Okay, now this PPI is interfaced to the stator winding through optocoupler and gate driver circuits. So actually this whatever PPI is there, that PPI is interface, and whatever logic sequence which is generated at this PPI, that logic sequence is applied to the driver circuit through electrical isolations. Okay, I have already discussed this opto isolator, the purpose of this opto isolator. So opto isolator is generally used to protect the control circuits, that is nothing but the microprocessor, from the faults which takes place on the power circuit. Okay, so these faults are generally in terms of short circuit, that may be in terms of open circuit, or that may be in terms of the transients in power circuits. Okay, now when we discuss the flowchart of this entire microcontroller based operation, then this is the flowchart for the controller implementation. So we provide input to microcontroller as a input stepping rate, the fs is nothing but the stepping frequency, and the direction, desired direction of rotation. So according to this input frequency or desired frequency, initially it will compute the time interval, that is t is equal to 1 by fs. So time interval is generally reciprocal of this frequency, and accordingly the timer count nc. Okay, so whatever timer, microcontroller timer is there, so that timer count nc and the time period t is computed. Then there will be setting up of the sequence byte address. Okay, so according to this calculated value of t, computed value of t and nc, there will be setting up of sequence byte address. Then this load, after setting up the sequence byte address, there is a loading of timer count nc, that will enables, after that, that will enables the timer interrupt. Then there is a certain time period is provided, so that is actually your wait command. So the due to this particular time interval, or there will be certain time in, you can say that time delay provided. So if timer interrupts, then there will be output sequence bytes. That means if timer interrupts, then there will be generation of output sequence. If timer does not interrupts, then again it will come back towards, or it will return back towards this wait command. Okay, so if the timer interrupts, so timer interrupts, if yes, then output sequence byte get generated, and that will provide it to the uh, gate driver circuit of your my stepper motor through opto isolator. Okay, So this will be the flow chart. Again, there will be certain modifications in this particular flow chart that depends upon the programmer to programmer. So depending upon what type of program or what program we fed in the microcontroller, there will be some of the or certain changes should be there in this flow chart. And according to this flow chart and the program which is implemented or program which is born on this microcontroller chip, the microcontroller will generates the desired logic sequence which excites the stator winding of a stepper motor. Okay, we are not going to discuss this programming part in detail because that is not part in your actual syllabus. You have to simply explain this block diagram and this flow chart. Okay, so if question asks for 10 marks or maybe for 5 marks, explain microcontroller based control of stepper motor, then draw this particular block diagram, write down explanation of this block diagram, the need of opto-isolator circuits, and if possible, you can draw this flow chart and you can explain this particular flow chart. Okay, so this is about the microcontroller based control of a stepper motor.